Alright, today we're taking a look at question 6 for Recitation 7. So this is when we have a square sheet with sides of 2 meters long at an angle of 60 degrees to a uniform electric field with that magnitude. We're looking for the electric flux through the sheet. And when it says direction of unit normal, that's just the direction of our n hat unit vector. That's what we're always calculating the flux for. So that's just what we're looking at. So I'm going to start by calculating our area since it was given that it's a square. This is just the magnitude of our area vector. Since it was given that it's a square with a square sheet with sides 2 meters, that's just going to be our 2 squared, and that's going to be 4 is going to be our area for that. Then I'm just going to copy down the electric field, the magnitude of it, because that was 1.1 times 10 to the 4th. That's newtons per coulomb. Then when we're calculating flux, what we're doing is we're finding the electric field times the area, but we're only looking for the component of it that's going to be perpendicular, where the two are going to be perpendicular to each other. So this is the equation I'm using. We have our magnitude of our area, and we have our electric field. So now we're just going to find this theta, and then we can plug that in for that. Alright, so I'm just going to draw our area over here. We're going to pretend that's a square, but that's just our plane. So then we have a look at our area vector, which is our a directional, right? That's going to be in the direction of this n hat, so that's going to be the n hat times the area, the magnitude of the area. That's going to give us this vector. So it's going to be in the direction of the vector that's perpendicular to the plane. If we do that like that, that's like our horizontal, that's our perpendicular. So then we're going to have our electric field at some angle just going off to the side. Then in the problem, it's given that there's an angle of 60 degrees in between the two, because there's an angle 60 degrees to a uniform electric field, right? That's what we're given. So what we have is we have our magnitude of the electric field, we have the magnitude of the area, and we have our theta, because if we're trying to get this perpendicular component, right, because that's when we're calculating flux, we're using what's coming through the surface perpendicularly. So we're getting this perpendicular component of our electric field, then we're going to take the cosine because it's adjacent to this angle. So then all I'm going to do now is I'm just going to be plugging that into our equation for flux. So we have the magnitude of this electric field is 1.1 times 10 to the 4th. We have our magnitude of the area, which is 4, and we're multiplying that times the cosine of 60, which is again that angle that we were looking at before. If we multiply all that out, that's going to give us 2.2 times 10 to the 4th. And again, since we're looking at flux, that's in newtons meters squared per coulomb, and that is our answer right there. Again, thank you all for watching. If you have any questions, let me know. If you have any other problems or anything that you want explained or walked through, I will do my very best to explain them, because I guess Sydney explains stuff.